Hello. Welcome to Friday session of Kahoot. So today will be the third session for chemical bonding chapter. It also is the last session for this week, and this is our first. I would say the results matters when it comes to our lucky draw for our giveaway. So what happened is we will be running the lucky draw today. As in all the results we have today, there will be 20 questions. Out of 20 questions, if you get 10 correct, you'll be automatically qualified for, your name will be qualified for the draw. So what we will do is today we will run the Kahoot as per normal. My admin, also called my moderator, will help to tabulate who has more than 10 questions and the entire list. We will do the draw on stream on Monday. So we'll make sure that all the draw will be done in a way that is open and recorded so that everyone can see that it's fair. Okay, then once so today, whoever has qualified for 10 questions and above, you're in for the draw. You don't have to aim for the top 3, top 5. No. All you need to do is passing mark, 50%. 20 questions, you get 10 correct, you're qualified for the draw. Name will be put on the wheel, and then we will spin the wheel on Monday to decide who gets it, and then that's pretty much it. So yes. Oh, hello. Okay, so if you were to comment and type on YouTube on chat, then you will have the Kirby, your own personal Kirby spawning. So yes, okay, we will start at around 9:06, 9:07. So wait for people to join in. So it is a Friday, and I heard that the new Jurassic World movie is up. So that's like some movie to catch, I guess, if you're in, June holidays, wonder what to do. But I heard the reviews are not very good. But if Jurassic World is your thing, dinosaur is your thing, guess it's something to look at. Else, yeah, that's pretty much. I mean, previously, maybe watching movies an idea. I mean, it's holiday. I think there's like 2 more weeks to go. So it's the 10th of June already. So yes. Okay, so we have 3 students, but some students disappeared. Interesting. So there's Takoyaki, there's JE, and there's Nicole. Hello. So okay, we'll start at 9:07. Anyone who would like to join, do join, because you never know. You might want to just try your luck, do your best, get more than 50% means 10 questions, more than 10 questions out of 20 correct. Your name will be pulled out for a draw. We'll be for this week we'll be giving away cash value of $100. Either is in, most likely is in NTUC voucher or Capital Land voucher. So you could just go shopping during June holidays. That's what we'll be giving away today. I mean, sorry, not today, but whatever we will be. Results will be based on today. The actual draw, the actual spin the wheel will happen on Monday. Hey Bob, hello. So we were about saying that today's, all you need to get is 10 questions out of 20, and once you get that, then you will be qualified for a lucky draw, and the lucky draw spinning the wheel will happen on Monday on stream, on record, to make sure everything's fair, no biasness going on, no collusion, no biases. So okay, so we have 2 more minutes to go. So you got Bob, you got Takoyaki, you got Jay, and you got Nicole. It's 9:05, 2 more minutes to go. And oh, one more thing, if you, I'm gonna repeat this again. If you ever put on any just type hi or something, or just type yes or something on the YouTube chat, you get to have your little Kirby walking on the screen. You get to play little games with it. Okay, I need to go check how much money I have. Currency. Do I have money? Show me my money. No? No, I don't know why. Okay, 9:06, 1 more minute to go. Oh, okay, I got 268 gold. Okay. Oh, okay, someone disappeared. There's only Bob, Takoyaki, and Nico now. No, don't run away last minute. Come back. In case, oh, Jay's back. Okay, in case anyone's late, feel free to join in. Technically speaking, you can join in at the 11th question, get all 10 correct, and you still qualify for the draw. So, I mean, whoever can do that, that would be like really cool, I guess. But yeah. Okay, it's 9:07. I think, to be fair, oh, Jiang, you think you broke? You got 78 gold. I mean, we could gamble and we can duel. We can do with that later. So yes. Okay, so there's it's 9:07 already. As promised, we should give this a start. So same thing. If you came in late, feel free to join in. Oh, Jay, no. Okay, we gotta give JE benefit of the doubt for 1 minute. Okay, come in, join, and let's move on. Yes, Jay is back. Okay, let's go. Okay, question 1. There's melting point, potassium oxide, calcium oxide. So give it a go. Okay, so what happens to this is there is red and there is blue. So in these questions, right, if you were to look at this, potassium chloride and calcium chloride is all about electrostatic forces of attraction. They are ionic compounds. So in this case, right, electrostatic forces of attraction is all about charges. The stronger the charge in this case, 1 plus, 2 plus, 3 plus. 3 plus is the strongest, followed by 2 plus, followed by 1 plus. Higher the chances of with 3 plus, the higher the chances for them to attract to each other. So it's not about reactivity, but rather the size of the charge. Okay, it's all about the size of the charge. Okay, so the second thing, this is something we call a very classic question. It's all about different ways of conducting electricity of different types of things. Ionic, covalent. Okay. In this question, right, if you look at the answer, the key and the important things that people make mistake here lies in the X, conduct only in aqueous solution. So what kind of thing only conducts in aqueous solution? It must be either acid or alkali. So some students, conduct in only aqueous. What about molten? Isn't it ionic? No. If something only conducts in aqueous and not molten, it's going to be acid or alkali, because acid forms H plus ion, alkali forms OH minus ion. So in this case, if you look at this, does not conduct in any condition, it should be a covalent. Conduct in so W should be covalent. So answer should be C or D. Then anything that can conduct in both molten and solid state, that's a metal. Y should be considered as a metal, so lead is metal. Then HCl is what I mentioned. It's an acid that conducts in aqueous solution only. And then the last one, conduct both in molten and aqueous state, which is ionic. Okay, moving forward. Okay, question 3. So be careful to try to filter your answer to know whether it's ionic or covalent. Okay, understanding is ionic or covalent first before you decide. Okay, in this case, overwhelming, everyone knows that if it's considered as a gaseous state in room temperature, it should be a covalent. Covalent should be non-metal. Well done, perfect. Well done. Oh, hi Lala, that's someone new. Okay. Okay, because be careful of this. This is selected for the alumina, silica. It's some school tends to use things like this. You may not be taught in school in terms of alumina, silica, so that was selected because of that difficulty. Okay, be careful. Yeah, it's insoluble in water, insoluble in organic compound. Okay, this one, what happened is, if you look at this question as a whole, it can conduct electricity when molten. If this thing can conduct electricity in molten, it most likely is going to be ionic. So automatically we are looking at alumina and sodium chloride. Anything that's R ends with an A. Alumina is actually aluminium oxide. Silica is actually silicon oxide, or so silicon oxide. In this case, right, silicon oxide or aluminium oxide, it ends with a R. So what happened is, the last one says it conducts electricity when molten. The high chance that it's going to be ionic. Answer either is red or green, and then it must be able to insoluble in water. This has overlapping with solubility table. Aluminium oxide is insoluble compared to sodium chloride because all spar salts are soluble. Answer will be alumina, red. Okay, moving forward. This is a second chance for whoever who just made a mistake previously and then learn from this. Okay, always look for the conduct in solid, match it with a metal, right? then the aqueous state or something something aqueous state something something acid something something alkali, right? Yeah. Okay. I think red and green is very similar. The only difference is the position for the metal. So always, I like to always position metals because it's the most special. Then position anything they conduct in aqueous state. Then after that, minus off everything else. So I can do elimination. So answer should be D. Okay, cool. Okay, question 6. Careful, figure out whether it's metal, non-metal, as well as the charge, so you can do crossing. Okay, in this case, answer would be B, blue. If you look at the answer, in this case, we can break down, right? Atomic number 19. Okay, if you take atomic number 19, it will be 2881, right? Whereas this is for Y. Whereas if it takes for X, its atomic number is 8. So 2.6. Last time, last number, this tells me that it's plus. 1 plus, this time is 2 minus. So Y plus X 2 minus, cross cross 1 and 2, you get Y2X. So Y2X, and then since last number is 1, it will be metal. Last number is 6, will be non-metal. Metal, non-metal is ionic. And then if it's ionic, it will be blue. B. So which substance is carbon covalently bonded to 3? So to some people this is easy. To some people it's not, because this is a very specific question. If you know and you revise, you will know only one type of carbon connects to 3 other carbons, leaving one freely moving electrons. Free moving electrons, and yeah. Okay, in this case, answer definitely be graphite. Good job. Everyone got it correct. Yay! Boron nitride is a man-made substance, consists of boron and nitrogen, can exist in crystalline form. Crystalline, okay. One of the form known as CBN is abrasive for cutting and grinding purpose. This cutting and grinding is very sus. So definitely this cutting and grinding seem this somewhere, right? Somewhere. So this cutting and grinding, only one specific material that you study is related to this cutting and grinding. Okay, so in this case, if you look at the answer, cutting and grinding is going to be related to diamond. Diamond, like drill bit, and cutting and grinding is always for hardness. It's related to diamond. Diamond is going to be related to covalent bond. There is a macromolecule. Macromolecule is another way of saying giant covalent structure. For number 4, green, it's also a macromolecule, but it says layers of boron and nitrogen with weak attractive forces. That's actually describing graphite. So yellow and green is very close, but then green is graphite, yellow is actually referring to diamond. Question 9. When sucrose is heated, it melts at 192. So in this case, it turns dark brown. So what's the conclusion? So in this case, there's two keywords. One is melting, one is decompose. So there is something, yeah, as I said, today is all the monster questions. So we picked this because of testing students' understanding on what kind of bonds broke or overcome in what situation. So when sucrose turns dark brown means that it thermo decomposes. Okay, in this case, right, I'd like to introduce this scenario. Let's say we have this, and then it's connected to. Okay, let's say we have carbon dioxide or something. Okay, I mean generally, as you can see, right, there are yellow bonding. The yellow color bonds, right, are covalent bonds, and they are intermolecular forces. So the intermolecular forces is going to be in charge of state change. So be it solid turns to liquid, turns to gas, or sublimation, anything related to state change is always related to weak intermolecular forces of attraction. Whereas when it comes to the when it comes to the strong covalent bond, so if this strong covalent bond is also broken, then it will just be a bunch of atoms. The molecules will cease to exist. When the yellow bonds are broken, we call this process thermal decomposition. If what triggers it to break apart is due to a thermal decomposition or thermal decomposed. So that means in this case, right, the molecules covalent bond is broken, it turns into atom, it decomposes. Atoms no longer stays as atoms anymore. In this case, let's look at this question. The question says that when it comes to sucrose, the sucrose melts at 192, and at the same time it starts to decompose. Where it changes color, that means it decomposes and melts at the same time, meaning its intermolecular forces and covalent bond is about the same strength, causing both decomposition and state change to happen together. Intermolecular forces are stronger than covalent bond. That's quite impossible. Reason is because intermolecular forces will always be weaker compared to covalent bond. They can be almost similar, but never intermolecular force stronger, because the only thing weak is intermolecular forces, not covalent bond. Covalent bond is always strong. And it says the covalent bond is stronger than the intermolecular forces for rate. That's most of the time. However, in this case, it says it melts and it decomposes at the same time. So this is some super tricky questions to test understanding. Okay? Osmium tetroxide has the structural formula shown. What is the valency of osmium? Valency. Okay, valency. So anyone who did questions on Monday and Wednesday would have known valency, because valency was asked on both days, and you also was asked how to calculate number of electrons for pictures like this. Okay, in this case, right, the valency of osmium, okay, this is where the tricky part is. Valency means how many electrons is shared by osmium. So you cannot times 2. There's 1, 2, if you count the lines, there's 1, 2, 3, 4, 5, 6, 7, 8. Osmium share 8 to gain 8. So the valency will be 8 and not 16. So it's selected to tempt student to go, oh, 8 lines times 2 is 16. So that's why this was a monster question. The main thing is valency is it gives 8 electron for bonding. Therefore answer would be blue, 8. Question 11, halfway there. So this question was selected. Reason is because of something about electrons not used for bonding, outer shell, inner shell, blah blah blah. Yes. Remember, you don't have to go for the top for the draw to qualify. All you need to do is do 10 questions out of 20. So spend some time, think about it. Accuracy is important here. Okay, in this question, answer would be green, D. Why? Because let's look at this. There are 1, 2, 3 lines. Each lines are 2 electrons. So in total, how many electrons are used for bonding? 3 lines times 2, 6. Answer can either be B or D. Then when it comes to number of electrons not used for bonding, you have to think about it in the idea of inner layer and outer layer. Okay, so I explained this just in case some people miss the sessions before today. So in this case, there's 2 O's and 2 H. So if you draw 1 O, 2 O, 1 H, 2 H, right? So you represent them by circles: 1 O, 2 O, 1 H, 2 H. So oxygen, oxygen, hydrogen, hydrogen. In this case, 1, 2, 3, 4, 5, 6. So there's lines on each of them. Oxygen is 2.6 and 2.6. So number 1, the inner layer, there oxygen, there's 1, 2 and 1, 2. That's not used for sharing. So in total, there's already 4. Whereas for the oxygen, that in this case, oxygen is 6. So 1, 2, we give out 2. It will be in how many will it be involved not bonding? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So there'll be 1, 2, 3, 4, 5, 6, 7, 8 of the valence electrons, 9, 10, 11, 12 of the inner electrons. Be careful, this is not difficult, but you have to be very clear. What is not involved in bonding? Is it the outer valence electrons or the inner layer electrons? So that's where things are tricky. Okay, answer will be D, green. Okay, question 12. This is a non-conventional questions. It's more of a try to figure out pattern. It was put in deliberately because it's difficult. So you may not know what coordination number is about, but you can look at the table, figure out the pattern, figure out the ratios. So yeah. Okay, answer for this will be Q2R. Reason is because if you look at the pattern, titanium, okay, if the coordinate, the cation is 6 and 6 is 1:1, you get NaCl. Look at titanium, if the cation is 6, anion is 3, then the positioning is upside down. The larger the number, the lesser the number in formula. So rather than T6 and 3, so you get TiO3. Whereas if it's PQR, look at the cation is 4, anion is 8, so it will be upside down in such a way that cation in this case will be Q should be 2, R should be 1, so Q2R. Answer will be blue, Q2R. Don't worry, that's a challenge question, so it's not a common question, so yeah. Question 13. There's QRZ of 4, 6, and 8. I will recommend using the periodic table and check the element's identity. Everything given here is related. You already know the formulas. These questions require students to check the periodic table to know the identity so that you don't make mistakes. Okay. Okay, in this question, right, answer should be okay. If you look at the table Q, R, and Z, Q periodic table Q has proton number 4. Okay, so in this case, Q will be proton number 4, so it's actually beryllium, which is 2 plus. If it's R is 2.4, is actually carbon, which you can understand as 4 plus, whereas Z will be 8, so 2.6 will be oxygen, 2 minus. So if you take QZ, you get 2 plus 2 minus, so it's like BeO, so it's QZ, followed by the second thing is, let's see, the second thing is RZ. So R will be carbon, 4 plus, Z will be O2 minus. If you cross, this is 2, this is 4. Simplify 1 and 2, you get CO2. So you should get RZ2. Whereas the last one of QRZ, RZ is actually CO, so it's carbonate, so CO3 2 minus. Q should be beryllium 2 plus, so it should be QRZ3. Yeah, so as I said, this question, right, is the only possible way to do it logically, possibly, is to make sure you know the element, and the element allows you to figure out the carbonate CO3. So that's that. Okay. The diagram structure shows ionic compound. This one you would require to use your phone, open eyes big, count the positive, negative ions, see ratios. It's important. What is a possible formula? the hint lies in counting the big circles and the small circles to see what are the ratios. The ratios will tell you that potential positive is to negative ratio. So big circles, there's 8 of them. Small circles is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So roughly it's about 8 to 15. So 8 to 16 lah. So it's 1:2. You need to look for the ratio as 1:2. Answer will be red, because red is the only one is Ca1, F2, 1:2. Answer is like, well, what about like blue? That's like 1:2. But in this case, right, if you look at this is a ionic. Only ionic has crystal lattice structure, giant lattice structure. So blue is going to, yes, it's 1:2, but it's covalent. So blue is not possible. Yellow is not possible because it's not 1:1. Then what about green? Green is also 1:1. So we are looking for 1:2 ionic compound. So answer will be red, CaF2. Question 15. Be careful of this. Question 15, we overlap. This question relates to strong acid and weak acid. It relates to acid chapters. Okay? So acid chapters. Something to do with something fully dissociates, something partially dissociates. Then you need to consider that with a covalent bond. As I said, it's a sneak preview to what we're going to do next week. In anyways, next week we'll be covering periodic table. In case you're curious, periodic table for the next week: Monday, Wednesday, Friday, 9 p.m. and Monday, Wednesday for practice round. Friday is still the same thing. Everyone who get more than 50% qualifies for a lucky draw for a giveaway. So in this case, which substance do not contain covalent bonds? In this case, do not. Yeah, we're looking for do not. Okay, in this case, right, answer should be 1 and 3. Why? Hydrochloric acid is a strong acid. Okay, so in this case, this question, it's overlapping acids with chemical bonding, so it's challenging in such a way. So HCl, so no, H and Cl, that's like covalent bond, but it's a strong acid. It fully dissociates. All the bonds, covalent bonds, will be broken the moment they dissolve in water, forming H plus ions and Cl minus. So in this case, there will be no covalent for 1. Okay, if you look at 2, ethanoic acid. Ethanoic acid is a weak acid, CH3COOH. Yes, it does dissociate, but it partially dissociates. Means that maybe 10% breaks up, then there will be a huge amount of them to remain as CH3COOH molecules floating around. So therefore, this contains covalent bond. So cannot do not contain covalent bond. Helium gas. Helium gas is a loner. Helium gas is noble gas. So when it comes to helium gas, it's just He, just alone. When something is alone, this is called monatomic. Means in this case there will be no covalent bond. Answer will be 1 and 3. And sulfur is actually S8. Sulfur is actually they rearrange the 8 things that looks a little bit like a crown, like a prince crown, with 8 electrons. 1, 2, 3, 4, 5, 6, 7, somewhere in the back 8. Okay. So 8 electrons is S8, so definitely contains covalent bonds. In this case, I repeat, number 1 has no covalent bonds because all bonds broken due to fully dissociate. Number 3 has no covalent bond because helium gas is monatomic. If it's monoatomic, it will be no covalent bonds. Answer 1, 3, blue. Okay, this is a good experience because you might need this example for your paper 2 writing. You can use this as an example for situations with no covalent, with all covalent bonds broken. Okay. question 16. Let's go. Question 16 refers to something called buckyballs or Buckminster fluorine and graphite. It requires students to be able to analyze complex structure and understand whether something can conduct or cannot conduct electricity. So you need to be careful. In this case, compare and contrast, something called discrete, something called giant. You need to be able to analyze those to tell which one is correct and which one is not out of the four. Okay, in this case, answer would be red, which is 1. Okay, so let's look at this. It says melting point of Buckminster fluorine is higher than that of graphite. Okay, this refers to the situation of what we in this chapter, writing question will use this word called discrete. What does discrete? Yes, Buckminster fluorine according to this has a formula of C60. If the thing is C60, it has a limit. Discrete means that the number is a limit. So that means 60 of carbon forms one molecule of Buckminster fluorine. So if something has a limit, discrete, it should be considered as simple molecular structure. Okay, simple molecular structure, SMS. Whereas if you look referring to graphite is like diamond. Okay, graphite has no limit. One carbon connect to 1, 2, 3. Then this connect to be another 3. And this connects to another 3. This connects to another 3. It's infinity. This is called a giant structure. So giant just means that it's unlimited. Okay, discrete means that it has a limited number. So if you compare anything that's unlimited, it definitely have a higher melting point compared to something that's limited. So this is giant covalent structure. This is simple molecular structure. So the melting point for Buckminster fluorine is higher because it's a discrete, it's C60 only. 1 is out. 2, Buckminster fluorine is a good electrical conductor. If you count, right, each of the carbon in Buckminster fluorine inside the football looking thing, every carbon connects to 3. Just like graphite, every carbon connects to 3. So Buckminster fluorine is actually a electrical conductor. The second one is correct. Number 3, Buckminster fluorine is a good lubricant. Lubricant requires two conditions. It has to be layer by layer by layer like a sandwich, and in between the layers should be held together by weak intermolecular forces. In this case, Buckminster fluorine is a football, not layer. So 3 is out, it's not a good lubricant. 4, on complete combustion, Buckminster fluorine forms carbon dioxide and water. So Buckminster fluorine is C60. It combusts plus O2. It has formed CO2, makes sense. How is it possible to form H2O? There's no hydrogen. There's no hydrogen to begin, so they would never have a product that contains hydrogen. So that's why number 4 on complete combustion is wrong. In this case, only 1 is correct. What is the 1? Buckminster fluorine is an electrical conductor. And what's the tips to decide whether something is conductive? You count the atom. If 1 carbon connects to only 3, the 4th is missing bonds. That will be a mobile electrons or free moving electrons. Question 16. This is included because when it came out in the exams, when I say exams, I'm referring to O-level. Student panic because like, oh no, I never seen this before. So ever since then, I think this came out in 2015 or 2016. Ever since then, every school loves to pick this question for their prelims. which I won't be surprised if we are doing your prelims, upcoming prelims, and you see this, you're like, ah, I think I see this before. So yes. So in this case, you need to be able to identify metal, non-metal, what is positive, what is negative, do the crossing. Oh no. Okay. So, okay, let's take a look at this question as a whole. Okay. Okay, let me clean the whiteboard. Okay. If you were to look at this question, it's an iconic question. So what happened is you have metal and you have non-metal, right? Metal is positive, non-metal is negative. Metal is going to be M, non-metal is going to be N. Okay, so now the ratio for every one positive is surrounded by 4 anions, negative. Then for every one negative is surrounded by 2 cations. So what you do after this, you multiply them, you combine, this becomes 1 times 2 is 2, 4 times 1 is 4. So you get 2 is to 4, and then you simplify, 1 is to 2. 1 is to the M, 2 is to the N. In this case, the final answer is M and 2. Okay, then in this case, if you 2 is here, 1 is here, you do reverse crossing. M should be M and 2. I wrote it upside down. So 2 is above the N, 1 is above the M. You reversed it. M should be 2 plus. This is where the 2 is given here. N will be minus. So this one N comes here. Answer will be A. M is 2 plus, N is minus. Formula is M and 2. Okay, question 18. Question 18 has very similar properties compared to what we did earlier on how do we tell whether something can conduct electricity. It's the whole calculate whether there's 3 bonds or 4 bonds, right? It's one of the crucial to determine whether something can conduct electricity in a giant ionic lattice. So this one has something called graphene. So in this case, the only difference is it has a bunch of hydrogen atoms attached on the bottom. Okay, in this case, right, answer would be 1 and 4, because what happened is it has actually 1 atom connected to 3 other atoms. The fourth is attached to a hydrogen. It's not able to conduct electricity. So by that, you will figure out answer is 1 and 2. It is still soft because it's layers of graphite. And then it will be 2 is giant molecular structure. Answer will be red. Okay, question 19. Which property of nitrogen is explained by a covalent bond and its molecule? So, what does covalent bond explain for nitrogen? So, nitrogen and covalent bond. In this case, nitrogen should be a covalent bond, to be specific, simple covalent bond, because because of a low melting and boiling point, a simple covalent bond. Yes, its separation from liquid air by fractional distillation is due to different boiling point compared to other gas as a mixture. But covalent bond is related to explaining why it has low melting and boiling point due to weak intermolecular forces of attraction under covalent bonds. Yes, last one. 20. Last one for the day. Hopefully everyone gets 10 out of 20, so everyone gets good chance. Okay? So this one I want you to calculate and think about this. There's tricks built into this as well, so be careful. I highly recommend drawing on a piece of paper, figure out the cross. Okay, yes, I expect some mistakes on this question. Why so? Okay, so now we look at YZ2. YZ2, I can tell you what's in my mind. So the first possibility of YZ2 is Y is 2 plus, Z is minus, cross, 2, 1, you get YZ2. Okay, second outcome is Y is 2 minus, Z is 1 minus, cross, 1 and 2, you get YZ2. So let's see, is it possible? Is there a group 2? There's no group 2. Possibility 1 is out. Is there a group 6? 1, 2, 3, 4, 5, 6. 3 is a group 6. Good. Is there a group 7? 1, 2, 3, 4, 5, 6, 7. This is a group 7. In this logic, answer should be 3 and 4. But if you look at the options, don't have 3 and 4. So what is the next possible, very rare scenario this will happen? So since it's YZ2, what if this is 4? What if it is 2? Cross. Y is some sort of 4 plus or 4 minus. Z is actually 2 minus. So when you cross 2, simplify to 1 and 2. Yes, this is why this question was selected. In this case, you are looking for a group 4. Group 4 refers to number 2. And a group 6. 6 plus 2. So in this case, this is group 6. So it will be 2 and 3 combined together to form YZ2. So in this case, answer will be yellow, 2 and 3, YZ2. This question is contributed in such a way that is very rare that students have to think about. Sometimes it's 2 plus 1 minus, 2 minus 1 minus. There could also be situation where it's exchange and then cross simplify. So it is tricky because that was selected. This is the reason. Question 20. Yes, so I have no so I have no idea how many students got 10 out of 20. Hopefully everyone. I will need to check with the moderator to run the outcome and see how, and draw everyone's name to put on the draw. Like I say, the draw will be put on Monday, done on stream openly right at the beginning. So even if you miss the stream, you can watch the VOD, you can watch the video on YouTube to know you have won. But anyway, if you have won, moderator would actually message you directly to ask what's your preference, how to process all that situation. Okay, wonderful. Really thank you for your guys' support to actually join this for this Friday, and you know, it's a weekend. So next week, Monday, Wednesday, Friday, periodic table, 9 p.m. Okay, so same thing. In case you have anything you want to ask, drop me a message on Discord. Else, have a wonderful weekend. And if you need anything, always message me. I do my best to help. Okay, thank you so much. So I'll see you guys most likely on Monday. Okay, have a nice weekend. Good night. Bye bye.